Good evening, students. So this time we are going to see about the learning outcome 2, which is given as from the second chapter, 2.3 it is actually. So develop a tool or equation or sketch to obtain the resultant electric field strength at a point generated by a nearby system of point charges. So which means you'll be asked with more than one charge, so you should be familiar with using two charges or three or more than three, four, etc. How to combine them and solve problems related to the electric field due to several point charges, and it's as mentioned in the book 30 and 31. So if you have read through it, so it's about the electric field, right? So we have seen the formula for force. Electrostatic force is 1 over 4 pi epsilon naught q1 or q1 q2 over r square, and electric field is the force exerted on a test charge, which is F over q naught. So when you substitute that in the equation, so F is this, so this divided by q naught, you will get the q naught get cancelled and you will be left with 1 by 4 pi epsilon naught q over r square, or which in other words this is k, so it will be easy for you to use in the formula. So kq over r square, this entire thing is constant, so k value is same, 9 times 10 to the power of 9, and q is the charge of which you are trying to measure the electric field at a particular point, and r is the distance from the charge to that point. Alright, and also notice that it's also a vector quantity, so the solution to this will require the math skill. Right, so what's the math skill required? You need to know how to combine this I've already taught you before in one of the previous videos. If there are two vectors acting at 90 degrees to each other, so this is the math skill. If the two vectors are acting at 90 degrees to each other, say F1 and F2, if you wish to find out the magnitude of the resultant net vector, so magnitude of the combined addition of these two vectors, F net will be equal to square root of F1 square plus F2 square. Right, and to find the direction you need to find the angle, so angle theta will be tan inverse opposite over adjacent, so your opposite will be F1, so F1 over F2, you will get the direction. So this is about if they are perpendicular to each other or at 90 degrees. So you have perpendicular vectors, or if the angle between them is 90 degrees. Okay, so you use these two formulae. So this you have learnt it in year 11, and if you have more than one vector, then you need to take the components. So you'll take the component of the third vector. So if you have F3, you take F3x and F3y, and you will combine it with the x and y or x and y vectors. So if I take this instead of okay, I'll take this is F1, this is F2. So in the x direction we have F3, the component of F3, which is F3x. In the y direction, a component of F3 also will act, which is F3y. Alright, so we will have to use both in the formula. So this you'll have to add with this, and the y direction will be F1y. So thereby you will find Fx and Fy, and then the next two steps will be similar to this formula. Okay, finally you will take square root of Fx square plus Fy square to get the magnitude, and theta will be tan inverse of Fy over Fx. So that's the practice that you have to be sure of, because for vectors, that is for force and electric field, we'll be using the same. Right, so now coming back to the question or application of this formula. So let's take this example 2.1. We have the details given here, and you are asked to find out the electric field at point P, due to charge Q1, Q2 and Q3. So you have three charges here, So we need to find out the direction of the electric field vectors and then combine all the three together. Okay, so there in force we used the repulsive force and attractive force to identify the direction, but for electric field we know that the field direction is outwards from positive and inwards for negative charge. So this is how you identify the direction of the vector. So I've just taken again the picture here. So if you have Q1, so Q1 is positive. So what will be the direction of the electric field by Q1 on P will be outwards, because it is positive charge. As I drew it here, positive charge will be outward direction. So you have the electric field at point P due to Q1 will be to the right hand side. So you write or label it as E1. So electric field E1 is to the right. How about Q2? Q2 is at an angle. So it's at an angle to P, and the electric field vector will be again outwards. Why? Because it is positive charge. So the two red ones are positive, so you have the direction outwards. Alright, so for the third vector, which is Q3, it's a negative vector, so it will be towards. So you have the vector towards the charge, so that will be E3. So these are the directions of the forces that is acting on the forces that are acting on at the point P due to charges E1, E2 and E3. Now a small tip for you. So if you are like not sure, you're confused, you are like okay, how do I go about this, I don't know anything, don't lose hope, because it is writing part paper. You just start finding out E1, E2, E3 by using the formula. What is the formula? So we saw here K Q over R square. So electric field E is K Q over R square. So you apply that formula and at least find E1, E2, E3. So you might score at least 50% of the marks. So this is KQ1 over R1 square. This is KQ2 over R2 square. E3 will be KQ3 over R3 square. Now look into the formula and see if you know the direct distances and the charges given. K is known to you, Q1 is given, Q2 is there, Q3, yes, you can substitute. Now what about R1? R1 is the distance of Q1 from P. So this is your distance for R1, which is equal to B. So this is B, and here this distance will be A, right? So I put it here as K Q1 over A is the distance. So what will be the value? 9 times 10 to the power of 9 times 1.5 times 10 to the power of negative 6 over A value is given as 8, so you put 8 square. Okay, so that's the calculation for E1. So if you apply all the formulas, you should be getting for E1, it is 9 times 10 to the power of 6. No, sorry, it is 375. We should get 375. What's a unit? Unit is very important. They have mentioned in the Heikel that there will be marks for unit. So remember, unit for electric field is Newton per Coulomb. So we have solved one. So it's like a step that you will secure at least 20 to 30% of the marks. So you didn't have to do anything, just a formula, you put the values, you got the answer, you will score some marks. Okay, now coming to Q2 distance. Q2 is here, this is your R2, but do we know the distance here? It's not given in the question. We use again math skill. This is square root of A square plus B square, because it's a right angle triangle with the sides A and B. Okay, so you have a triangle like this with the sides. This is A, this is B. So the third side you can find by using A square plus B square. Alright, so you will substitute the same formula here. So 9 times 10 to the power of 9 times the charge q is 2.5. So 2.5 times 10 to the power of negative 6 over this. You can separately find this. It is 8 square plus 6 square root. You will get 10. Okay, so it's square here, so it is 10 squared. Be very careful with the substitution. If you miss a square in the denominator, your whole answer might go wrong. So that should give you 225 Newton per Coulomb. Okay, so E3 is also very similar. So you have 9 times 10 to the power of 9, and this is negative 3.5 times 10 to the power of negative 6 over the distance is 6 square, and you should get negative 492 Newton per Coulomb. So we have found what electric field E1, E2 and E3, and the next step is, by using your math skill, you should combine the three vectors. That's a bit a little confusing for many students, but if you practice 2-3 times, you will get it right. Okay, so I'm just drawing that again. So you have E2 in this direction, which is not at 90 degrees. E1 is already in the x-axis, so we don't have to do anything with that. This is E3. So E3 and E1 are already on x and y, so we will just split only E2. So E2 should be split into its x and y components. So you need this theta also. This angle is not given in the question, so our aim is to first find theta and then split it into x and y components, x and y, and then use the formula. Alright, so here E2 will have a component in the x direction, so we put that as plus E2x because it will be in the same direction. Okay, E2y will be up here, so E2y is going in the up positive direction. This is downward is E3, right? So when you're putting it in the formula, so Ex is equal to E1 plus E2x. So I've taken this and I put it here. Okay, that's your x. But Ey, since they are in the opposite direction, E3 is down, so it is Ey will be E2y minus E3 because they are in the opposite directions. Okay, so first we'll find theta and then come back to this equation. So how do I find theta from the given? Because this angle is theta, so the same angle will be here as in theta, right? Both will be at the same angle. So I can use once again tan inverse y over x. In y we have a, so it is a over b, which is a is 8 over tan inverse 8 over 6, which should give you 53.1 degrees. Okay, so you found theta and then expand this formula, and Ex, Ey you can find. So Ax is equal to E1 is how much? 375. So 375 plus E2 is 225. So 225 times its x component. So we take the cosine theta. So cosine theta. Ey will be E2y is y component. So 225 is E2 times sine here you can write 53. This is sine 53 minus E3 is 492, right? So you substitute all the values, and for Ex you should be getting 510 Newton per Coulomb. Ey you will get negative 312 nanocoulomb. Sorry, Newton per Coulomb. So we got Ex and Ey. So the next step is what? To find E net, or the total electric field. Formula is Ex square plus Ey square, so which is 510 square plus minus 312 square. You should be getting 597 as the answer. 597 Newton per Coulomb. Okay, now this is what magnitude. Now here if they ask you direction, this is different, this angle is different. This angle is what? It is the net. Many students ask me, Miss, why this angle is different and why do we have to calculate again? This angle we are calculating for components of E2. That's not the final direction of all these forces combined together. So this is your net, E net, and we are trying to figure out where is the E net acting. What is the direction it is making with the x-axis. This theta is different from the previous one that we calculated. Here you need to substitute tan inverse, not A or B. It will be this Ex and Ey. So here you should substitute negative 312 over 510. You get negative 31.5 degrees. Notice you get a negative sign which shows that the electric field is downwards, and this angle is 31.5 degrees. So that's how the whole solution for this question goes. I know this might sound or look complicated, I do agree, but split it into two sections. Section 1 is find all the electric field by the charges without even thinking about how to go to the next step, and then give it a thought. Okay, how do I combine the vectors? Okay, so to make you feel better, there is another question that I've chosen. This is an easier version. This is not very complicated. It's an easier version question. So those of you who find the previous question difficult, at least practice this and be sure. Okay, how is this question easy? Because you will not, there is no component here. I'll tell you why. Now here again there are 2 point charges, so let's take this as q1 and q2, and you need to find the magnitude and direction of the field at the third corner of the triangle. So third corner is this, so your P is here, and they ask you what's a net electric field. Okay, as before, first, as I told you, first step, E1 you can find and E2 you can find. Why? Because the distances are known to you. Distance between the point P and Q1 is given 10 centimeters, and from Q2 to P is 20 centimeters. And you always have to write it in meters, so you divide by 100, it should be 0.2 meters here. This over 100 should give you 0.1 meter. Okay, so K Q1 over R1 equals 9 times 10 to the power of 9 times the charge Q1 is negative 10, so negative 10 times 10 to the power of negative 6 over 0. Square is there, 0.1 square, and this should give you 9 times 10 to the power of 6. 9 times 10 to the power of 6 Newton per coulomb. Now this is also KQ2 over R2 square. So Q2 is 15 microcoulomb. So you convert it to coulombs by multiplying it with 10 to the power of negative 6. The distance is 0.2, so 0.2 square. This should give you 3.38 times 10 to the power of 6 Newton per coulomb. And this is a negative sign here. Okay. Now after solving this or writing these two, it's not very difficult. It's an easier part of the question. So you can calculate that. You will definitely get some marks out of 8 or 10. Okay. Now going to the second step, which is to find the direction of the electric field. So what is the direction of the electric field by Q1 at the point P? Now it's a negative sign, right? Negative is you will have the field direction towards it, right? We said for negative, the direction is towards the charge. If it is positive, it will be away from the charge. So here, the field is, E1 is in this direction, right? And how about E2? This is positive charge, so at point 2 you will have it on the left side, so E2 will be to the left. So if I redraw this, you have both vectors, just two vectors only at 90 degrees to each other, right? So what did I mention initially when I said math skill? If they are at 90 degrees, how will you add them vector in a vector way? E net, or the final E, will be equal to square root of E1 square plus E2 square. That's it. There is no component required here. Why? Because you have all of them acting at 90 degrees, right? So we'll substitute the values. So E net will be equal to square root of 9 times 10 to the power of 6 square will be negative, plus 3.38 times 10 to the power of 6 square. So this should give you 9.61 times 10 to the power of 6 Newton per Coulomb. So that's a magnitude. So how will you find the direction? Theta is tan inverse of, which is the y direction. Y is E1 and E2. So you put minus 9 times 10 to the power of 6 over 3.38 times 10 to the power of 6. So you will get negative 69.4 degrees. So when it is negative 69, so again it is in the so the angle is negative 69.4 degrees we got. So that is, so you have it here as 69.4 degrees, or if you want to take it from x-axis, this will be 180 minus 69, around 110 degrees you will get, okay, from the x-axis to the left. So that's the whole solution of this equation question. So as I told you earlier, when you have just a vector at an angle, you will have to use the component method. That could be difficult, but please practice by using even forces. You have similar, only change is what in forces you will have the formula kq1 q2 over r square, and the unit will be Newton there. For electric field, formula is kq1 over r1 square and the unit is Newton per Coulomb. So try to differentiate, compare and study so that you don't confuse both, and hopefully it's easy for you. All the best, students.